How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a crank pulley off a 3306 Cat engine that's come in to have the seal surface reclaimed. The 3306 engine has many different applications. It can be used in earth moving, marine, or even for generators. The engines are often found in your D6 and D7 size dozers. They're also found in the 637 scraper, some of the graders, water carts, and some of the dump trucks. This pulley mounts onto the crankshaft of the engine and it transfers power from the crank through the rest of the accessories like an alternator, a water pump, or any other bits and pieces that are attached. This pulley was actually removed off an engine out of a 637G Cat scraper. As you can see, there is a groove right around the diameter of the sealing surface, and that was caused due to debris and dirt getting in under the seal, and then it basically creates a grinding paste and it wears away the seal surface. There really are only two methods I would use in order to repair this. We could machine that down and fit a sleeve and then machine that back to size, or it could be metal sprayed and then machine back to size, which is the method I'm going to use. The reason I've chosen to go metal spray over a sleeve is sometimes sleeves can leak. Although they are a tight fit, you do sometimes get weepage of the oil coming through the sleeve, and metal spray just eliminates all of that. So to do the metal spraying, I am going to be using my Eutectic Rototec gun. It is a cold spray method. Although it is very, very old technology, it still works extremely well for these sorts of applications. You could also have that seal surface reclaimed using HVOF, HVAF, or thermal spray, which is an electronic process. They're all pretty much the same. It is still a metal powder that is being sprayed onto the job, and then the heat from the flame or the HVOF is bonding it to the material. So this Rototec setup, it is about 52 years old, and as you can see, I've still got all of the paperwork and the manuals that came with the kit when it was sold originally. And we still have a lot of the original powders that aren't even open, because in today's age there are a lot of other different powders on the market that are slightly better than what was made 50 years ago. So the gun is made up of two parts. You have the frame, which you screw your bottle onto, which feeds metal powder down the torch, and then you have the handle, which has the taps for regulating the gas flow and the intensity of the flame. So this process involves three steps. There is prepping the part, spraying on the new metal powder, and then machining it back to size. So the first thing we're going to do, we're going to get into prepping the part. Righto, so I've got that dialed in. It's to within 0.01 of a mil, which is less than half a thou. Next thing I need to do, I'm going to clean up the surface, get rid of all this paint, any rust or loose debris, and that is so I can then apply the masking compound. So the masking compound I'm going to be using, it is not the Eutectic brand. It is what our supplier here in Australia brings in. But it is the exact same sort of thing, it's just a different colour. What the masking compound is designed to do is stop the metal spray sticking to areas you don't want it to, and it's so you can isolate where the powder goes. And I like to apply the compound quite thick. I don't just brush it on, I do dab it, and that way I can get a very thick layer. And because I've got such a thick layer, the spray powder can't penetrate the compound and get into the parent material. And when this dries, it is extremely easy to remove. You just need to give it a light emery. The Eutectic style, once it dries, it can be very difficult to remove. So we've applied our compound. That's going to take about 15 minutes to dry. So the compound's all dry. What I need to do is undercut the area that needs the repair, and I'm also going to put a rough thread through that, and that is to help give the new layer of material something to bond onto. So 91.95 is the finished size. That's 90.5, so that's pretty good. So we'll just thread it. I think I want to slow it down a little bit. Righto, so we've got the gun set up now, we've got all the gas hooked up to it. I do need to preheat the part up to about 95 degrees. Once we achieve that, we can then put the powder on and start applying it. And the powder we're going to be using, it is a high wearing powder, it is a 960 grade, and it is a one-step powder. So we don't have to put down any sort of primer or any bonding agent. We can just shoot the powder straight onto the job. So to get the best results, there are parameters you need to work within. There is a recommended turning speed based on the diameter of the job. Because this is roughly 4 inches in diameter, the recommended turning speed is 48 to 115 RPM, and I'm running it at 90 RPM. And when you're using the gun, you need to have it in a horizontal position, perpendicular with the workpiece while it is rotating, and the distance between the workpiece and the torch is about 6 to 8 inches. And the flame settings are also very important. If you have it too hot, you will burn off the material before it gets applied onto the job, and if it's too cold, it won't bond and it won't stick together. So we've got our metal powder sprayed on. I did build up about 5 mil of material, even though I really only needed about 2.5. I'd rather put extra material on now rather than have to come back to fill in any blanks or redo the repair again because there was a void. Putting that amount of material on there only took about 10 minutes to apply. Now that that's done, we'll let this cool down, then we can come back and machine it to spec.
Quick! Oh, jeez. Good boy. Oh my God. Hey, hey, sit. Spin around. Good boy. Oh my goodness. I guess you like them.
Righto guys, so the part's cooled down enough now. It took about an hour and a half for this to come back down to a temperature where we can touch it and start to finish machine it. So the finished diameter we are aiming for is 91.95 mil. I will bring it down to 92 mil, and then I will finish it off the 0.05 with some emery cloth. So I'm going to rough machine this with a W&MG insert because they are quite robust and they will put up with the punishment of an interrupted cut. After I've done that, I'm going to use a TNGG insert for the final passes. Now, bits are going to break off because of the masking.
Okay.
So just be aware. that material that just fell off, that was due to the masking compound. After you machine it, it just falls off. The insert didn't really like that sort of RPM. This is quite a hard material once it's been applied, so I'll slow it back down and hopefully we'll avoid burning inserts. It's 92.005. Yeah. Hard to burn sandpaper. We have to machine more off. That's just not even cutting. One to come off. Still 0.01 to come off. Wow, that stuff's hard. So this material is really hard. The emery tape isn't really doing a great deal to it. It's not actually cutting material away. So I am going to change over to a zirconium belt, try and reduce that down to 0.01 we need. I don't want to even try and do that with an insert because I do need to speed it up in order to get a better surface finish, but I might end up burning the insert and messing up the job. Nearly. Righto guys, so that's this repair complete. I'm really happy with how it all came out. We achieved a really good surface finish, and the lay we put on there is extremely hard. It's definitely going to hold up a lot better for where that seal sits. To buy a new one of these is about $1,800 Australian, and that's if you can find one. So all up, this repair took just under 2 hours, but that doesn't include the time for the masking compound to dry or it to cool down after it had been sprayed. On top of the time, there is a little bit in the consumables, so this is a very economical repair for our customer. The last thing I need to do is spray on a rust preventative onto the area I've just machined, then we can get it back to our customer so they can get their engine reassembled. Thanks for watching. Right, wait, this is just audio?
Yes.
Right. How'd you start it? How did I start it? How we started? Oh, wait, how did you start it?
Righto, guys.
Yeah, and right, are you ready?
I'm ready.
How you going, guys? Curtis from Cutting Edge Engineering. Today's job. Oh wait, how we doing that? And the. Oh wait. Oh wait. So the. So the thicker the barrett, the thicker the layer you put on. Oh fuck me. And I prefer to. Oh fuck me. Hang on. It's not funny. It's not funny. Stop fucking laughing. Fuck train. Right. Fuck train. Now that our compound's dry, I'm now going. What do you want?
Oh, I don't know. Just
Right.
not now and now. How you said now twice.
All right. Shit. Need more words. Big. Not because. Fuck. Fuck. Oh fuck me. Hang on.
Wow. 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 Okay, slow down. Hey, your next Curtis from Cutting
got
Edge. You don't.
No, I don't like it. I don't like it at all.
Just redo the whole thing.
Right.
Cool.
Stickers.
Are they really?
Yep.
What? Alright. Oh, it was in there the wrong way. Someone didn't put it back correctly.
That
Maybe
was me.
redo that. Cover it up. Holy smokes, that's quick. What, is that it?
That's
One
it.
more?
Oh, that's it.
Russell! Very noisy. Oi, where's your ball? Where's your toy? What's that? Where's your ball? What's over there? Go find it. Go find it. Oh, quick. It's raining. It's raining. Oh, my God. Wait, what? Hang on. Stop, stop, stop. No, 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 no. No more. One's enough.